In this problem, we are given two strings. String x has length n and string y has length 2n. You need to write an algorithm that identifies whether y has a specific form, has a specific structure. Does y have inside of it x, and in such a way that preceding portion of y is some suffix of x and the remaining portion after x in y is some prefix of x. Notice that AB is a prefix of x and CDE is a suffix of x and ABCDE is x. So this specific y example is a correct structure of y, and your algorithm with this y and this x will return true. How to solve this problem? We don't know what y is at the beginning of the algorithm. Your program only needs to return true if y has this form, or return false if y doesn't have this form. And your algorithm should run in linear time. We know that you can build suffix array and LCP in linear time in O of n. So how can you use this information to solve this problem? We can, what you can notice is that because there is suffix of x precedes x, then if you take an x and concatenate x in front of it, then from this first x you will have all possible suffixes that can be appended to this x that is inside of y. And from this x, if you append another x, then from this following x you can have all possible prefixes from this x. It's very important to notice that if you have an x inside of y, this x, then you will not get prefixes from this x if you touch it in front of it. You only can have prefixes from x that follows this x, because all the prefixes start from the beginning of the x and go to some ith position in the x. And the same true here. You cannot get any prefixes attached to this x from this x. You only can have suffixes from this x, because suffixes end with the last letter and start with some letter inside of x. So if you attach x, 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 then you will have x inside and all possible suffixes from this x and all possible prefixes from this x. And after that you can then attach pound sign and concatenate y and concatenate $sign. In this case you will be looking at the string x, 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 pound y and $sign. In this case, what do we have? Because y has form x and some suffix followed by remaining prefix, if y has this x, if y has this form, then it should be somewhere right in here. You can find it, y in this string. Let us show if it is the case. So if we have a, b, c, d, concatenated with A, B, C, D, concatenated with A, B, C, D, you can see that this is our internal x, and if y is C, D, A, B, C, D, A, B, then this would be your y, C, D, A, B, C, D, A, B. And in fact, whatever suffix is and whatever remaining prefix is, if y has that shape, then you will have y inside of this string. Then how do you write solution for this problem? using this concatenated string, you first need to say build this string. So let's write down first step, build this string. Yeah, you can call it something, let's call it C. Then build suffix array and LCP on T. You need always to specify which string you build suffix array and LCP on. And then what do we do? Then we scan LCP and if LCP of I is equal to n, to actually 2n, because y is of 2n length. So if LCP of I is equal to 2n, we also need to check whether these suffixes that have common prefix equal to 2n come from this string, xxx, and y string, because this can be also true for one of these strings. This string has 3n length, so it could be the case that some suffixes match other suffixes in 2n characters. For example, if you have a as x as a, and then another a, this is our second x, and another third x, let me see, 5 and 3, 5, and another x, and pound, then you will have 2n suffixes, because this suffix starting at this position has 2n, and if it matches with the suffix that starts at position 0, a, and so on, suffix that matches at position 0 and at position n will also produce 2n result in this case. Therefore, we need to make sure that starting positions of the suffixes whose LCP is 2n come from xxx and y. So you need to state it. Check SA of I is less than 3n and SA of I minus 1 is greater than 3n. Why do I use SA I minus 1? Because LCP of I is between two suffixes, suffix at ith row and suffix at I minus 1 row. And this knowledge is also tested in the test. Check if this is true or vice versa is true. If it is the case, then we continue checking if we need to check more. But in this case, we don't need to check more anything. So if this is true, then return true. If all of this is true, we return true. And the reason is that if LCP of I is equal to 2n, and SA of I is less than 3n, that means this substring comes, one suffix comes from xxx and another suffix comes from y, and if it comes from y, that the only characters that can match xxx is the entire y, because these characters do not occur in x or y, and if entire y matches with the string, then it must be the case that it has this shape. Another solution for this problem, there is another solution for this problem, and let me explain you two more solutions for the same problem. If you look at this problem at a structure of y, and you can notice that Because this is any suffix of x which then followed by x, then this x will contain the remaining prefix, namely portion of y that comes after x. But this x, internal x, also will have this remaining prefix. Here it is. It will have this remaining prefix. And if this is a suffix and this is remaining prefix, then this remaining prefix, if we take it, then this x will have the remaining suffix CDE. And we know that AB is remaining prefix, and this is a remaining prefix, and CDE is remaining suffix, and CDE is remaining suffix. So this portion is equal to this portion, and prefix is equal to prefix. That means that 1, 2 is equal to 1, 2. So CDE AB should be equal to CDE AB. Once you made this observation and use this reasoning, you can cut y in halves and make sure if y has that form, then the first half of y must be equal to the second half of y. And in this case, you write a solution like this. Let string w be equal y from 0 to n minus 1, and z be equal to y starting from index n and going to n minus 1. Index starts with 0 and length is 2n, so the last index is 2n minus 1. Now when we name these strings, we need to check that they're equal. So check that w is equal to z. This is done in O of n time by comparing each corresponding indices. Okay, and then if it is true, then we still need to make sure that this first half, which is equal to the second half of y, is a circular shift of x. And for that we need to do the following. 3 build a string xx pound y $. In this case, we will make sure that suffix of this x is concatenated with prefix of this x, and then y matches this concatenation of a suffix and a prefix. That means y will be a circular shift. And we also need to build LCP suffix array and LCP longest common prefix array on this string. Let's call it T, on T. All of this is done. This is done in O of 3n, which is actually 4n, which is O of n. This is also done in O of n. And 5, scan LCP if LCP of I is equal to n. I'm sorry, we don't build it on y, we build it on w. Let me correct it. This we will build on w, on just half of y. So this would be not 4n but 3n. So scan LCP if LCP of y is equal to n. That means w matched some middle of this string. Then we need to check one more thing. Check that suffix array at I comes before 2n, and suffix starting position of suffix at I minus 1 comes after 2n. If all true, then return true. This is the second solution of this problem, and let me show you the third solution of this problem. So the third solution of this problem will be to notice that in fact if x occurs in y, then you can simply find it using this match using suffix array and LCP, and then do some other check that the remaining portions of y correspond to suffix and prefix of x. So again, that means that you can just build a string x pound y $. Y is 2n, x is n, and what we're looking for is match x inside of y. So second, find build SA and LCP on this T, let's call it T, and then scan LCP. If LCP of I is equal to n, check if these positions of corresponding suffixes belong to x and y, because actually y can match with y itself. Look at this, SDAB is equal to SDAB, so LCP of I equal to n might come from y. So we need to check that our starting positions actually come from x and y. Check that SA of I is less than n, and SA of I minus 1 is greater than n. This tells us that match is between x and some substring inside the y. And now we need to make sure we found x inside the y, and we know at which position we found x at, inside the y. And this would be or vice versa. And at position at step 5, we need to let SA of I be inside the y. So let me put it greater than n. And then we know position inside the y where x occurs. It's right here at SA of I. Now we need to take the portion of y that comes before and portion of y that comes after. Because this supposedly is a prefix and this is a suffix, we need to concatenate a prefix followed by suffix and check if it is equal to x. Let me call it like let P is equal SA of I, and apply some formulas. So if this is position P, then from 0 to P minus 1 would be suffix of x. So let W be let W be x pound y $, at starting position 0 to position P minus 1, and let Z be substring of this string starting at position P plus n will give you this position. This is P plus n. P plus n is the starting position of the prefix that ends at position, let's see, 2n plus 2 more, 2n plus n, 3n plus 2 more characters, 3n plus 2 minus 1, so it would be up to the end of the string, so it would be 3n plus 1, the last index. So this would be substring z, which corresponds to prefix. Then what do we need to do? What we need to do is to concatenate them. We concatenate them, compare 6, compare that x is equal to concatenation z followed by w. If it is true, return true. If true, return true. So this would be the third solution for this problem.